Yes, 330 out of 600, right? Which would be 0.55, okay? So if you didn't get this down, just make sure we get it down here. This one is 0.5625, and then this one was approximately 0.536. Awesome. Right here, right here, right here. Okay, so question, are these independent or dependent? Hit it just a little bit. These are actually dependent events because the probability of English given female, does anyone know what this is called? What type of?
Conditional probability.
Yes, Wayne, give yourself 4. That's great. This is conditional probability. Given that you are female, what is the probability of being English? We found it there. And then the probability of being, or preferring English, the fact that you're not female would be 0.536. These three are not the same, therefore these events are dependent. Nicely done. We'll talk about this in a second. Really quick, we're going to give you a second scenario. In your group, I'm going to give you the numbers here. This is 176, 154, 144, and 126. Really quick, I want you to solve for number 9 in your groups, the people around you. And then also, in number 10, I want to see if you can answer number 10, and I'll go through 11. So hold it right there at number 10, or after number 10. And I want you to go through number 9 and 10, see if you can solve it. Ready, set, and let's do this. Go ahead. I'll give you a couple minutes. You don't have this one? Gotcha.
Yeah, so that's just.
Do you have your note sheet, by the way?
Oh,
Do you have this one?
you know what? Yeah.
Let's just say everyone has another word. So
I thought we were gonna do it.
Gotcha. Just want to make sure you have it.
I did it before you said it. Fine, sir. Obviously. I did it.
No.
You're getting pretty good.
Once someone's done, let me know. Yes, ma'am.
Okay. I have a question about what is that?
Okay.
Yeah, what is that? Where do you see okay?
Actually, just I don't know why. If I could do something else, I do like a.
What's up?
I was like, what is this?
Okay. Oh,
I was
like
really confused.
when you go like the O, and then what you would like the. Oh, it's okay. Like
This marker sucks.
okay.
It does. I can get some.
I had a question.
I'm getting cards. I'm getting cards.
I understand that,
You do?
but like
Gotcha. Do this. I think it will help find the probabilities using the chart up. Cool. And then I think it will. Once you get those done, call me and I'll tell you. Does that make sense?
yeah.
They won't be because I changed the value.
Oh.
Do that and then call me over. And then
Will
we'll
you give me another marker?
yes, ma'am. Try these. Try those because I don't know.
No.
Did you find those down below?
Yeah, me too.
This one is 176 over 320. The reason, do you know why?
Oh yeah, because it's not female. Oh yeah.
Mm-hmm. So this one is 0.55, right?
I was sitting there all the same.
Nice. Hey, remember given, right? Do y'all remember the given, the conditional probability? What is the probability of being English given that they're female? So if I'm given that they are female, you've got to focus in on the top yellow part. You remember this a little bit? So it'd actually be 176 over 320. Because you're focusing not on the total, but on the ones that are female. Does that make sense? Did y'all get it? What'd you find out about it?
So it's like
They're all the same.
this is that. I don't understand.
I think all of them are 0.55. Is that right? Cool.
This one's out of 2.
Did y'all find it?
Yeah,
What'd you find about all of them?
they're all the same.
They're all the same. Okay. What was the fraction over here, Torrance?
It was 154 out of 280.
Good, good, good. Okay, we're going to talk about this. So what do you notice about
154 for the.
154, because it's this one. Yeah. Good. All right, let's talk over this now. Big concept here, especially on the test, and we'll keep harping on this. What did you notice about number 7 and number 9? Comparing those two. Number 7 was the ones we just filled in above it. Number 9 was the ones that you just did in your groups. Claudia, what'd you find out?
Well, all of them, like 7 and 9, are all roughly the same. They're around 5.5, between 5.4 and 5.6. But in number 7, there's a little bit of variability, but then in number 9, they were all 0.55.
Yeah, they're all equal. So which one's independent? Give yourself 2 on that, Claudia. That was good. Which one is independent? Charles?
Number 9.
Number 9. Good. Do you know why?
Because none of the values changed. Like none of the events changed the next one.
Good. Think about this now. Remember the independence. Give yourself 2, Charles. That's good. Remember independence. The probability of event occurring does not change given that something else has been given to you. You say, Coach, what are you talking about? Well, let's write this down. Let's see if we got it here, okay? When they are not independent, when the events are not independent, when they are not independent, like number 7, you could kind of stay on number 7 that it's not. When they are not independent, the probabilities were different, okay? But like Charles said, we're different. But when they are independent, what happened? All the probabilities were the same. When they were independent, the probabilities were the same. The probabilities were the same. All right, here we are. The same. Such as number 9, right? Number 9, that's the second one. The first one is dependent. That's number 7, okay? Think about it. Does the probability change if my first card was a black card and I left it out and then chose a second card? The probability will change, right? But what happens is when that probability does not, we say that in this case, number 9 was independent, okay? Does anyone maybe have a question on that? Ryan, did that make sense for you? Because I knew you had a question on it. Perfect. Okay, so how can we generalize this? We're almost done with this. Go ahead, Fiona.
Can I tell you how to generalize it?
Please,
Is it
yeah.
okay? So if events A and B are independent, then the probabilities are the same.
Good. Probabilities are all the same. And what are the 3 probabilities?
So probability of English,
Perfect. So we're just going to label A as English, right? Is equal to the probability of?
B plus A, or A plus, wait, yeah.
So probability
so
of
A
given
given B,
B. Good. And it's also equal to probability of A
given C.
given.
Wait, the B with the C.
Nice. Yeah. B complement. Give yourself 2. Great job. Okay. So it's independent if we can prove these 3 things. Probability of A is equal to probability of A given B and is equal to probability of A given not B. Right? If you can prove that, that's independence. That is our independent rule that's there. Okay? So that's kind of the big idea. We showed that here, showing the difference between the 2. Questions on this? All right, let's keep rolling here because y'all are rocking. Let's go to this next thing. Y'all need me to go back? I'm sorry. Y'all good on that? Y'all Gucci? Y'all fur?
Fur.
Can you just hold up? Did I tell you all this?
Yeah.
I look like an idiot with.
Yeah.
Oh, was that y'all's class? I did. I look like a complete moron. Thank you, by the way, for helping me out.
We thought you figured it out.
Well, obviously I didn't I? Appreciate y'all. All right. What did I do? Did I do something else?
Oh.
Am I like cussing when I say for real? Oh, okay.
Far.
That's happening. All right. Golden Nugget. Did y'all get this down yet?
Yeah.
If you didn't, go ahead and get it down. While we talk through it, just want to talk through it. We've gone through independence, the definition. We've gone through the generalization. I don't feel bad about that. What I do want to just talk through is how do I find this? Well, this right here is on your formula sheet on the AP exam. Okay, so you can actually use your formula sheet for this unit coming up for this test. the probability of A given B is equal to the probability of A and B divided by the probability of B. I'll give you 6 tickets if you could tell me what is the way we solve for probability of A and B. Go ahead,
You
Torrance.
just add them up, right? Like,
Okay, when we do or, you're right, we add them up. We add, right? But when we do and, it's a little bit different. Grace, I don't know if I've called on you yet.
Is it you add them or? Wait.
Yeah.
Got it. It's you add P, and then it parentheses A with P parentheses B, and then you minus P, and like the added P and B.
Okay, that, I'm going to give you 2 tickets. That is when we're talking about or, right?
Oh, okay.
Or, what about and, Torrance?
so like you add the probability of the first one and then the second one, and you subtract it by the probability of both of them, right?
That's what Grace said. You're right, Grace said that. What is and? When?
You start out with P, A, or B, then you subtract A and subtract B.
Okay, not quite. That's good thoughts. I haven't talked about this. And means multiplication.
Wow.
Good.
Probability of A times probability of B. We'll talk over that in just a second, okay? Now, how many of you are struggling on the difference between mutually exclusive and independence? Is there anyone?
A little.
A little bit fair. I would say that was a big thing last year. Here's what I decided to do. Do you have that extra sheet I gave to you today? It's like a little chart. This right here is for your study, okay? I kind of scaled back the amount of stuff we were going to go through today so that we can hit this, because I think it's important, okay? All right, so here we go. We're going to just go through, and then we're going to do an example, and then we're going to be out of here, okay? All right, here we go. Key topic, if I can reach this.
Wow.
Whoa.
You do this to yourself.
Why do you have to jump like
Probability. Problem. This is a true story. 3 years ago, I had a putting green up here that was an elevated green. It was awesome because I was like my platform, and I could reach up there. So I know I do it to myself. I get it. All right, here we go. Why do we do this? Why are we using this? Because we want to select the right strategy, okay? The right strategy. And that's why we're just going to put this up. This is for your help. This is for you. The main idea we have two. It's the or idea versus the and idea, okay? We're just going to roll through this. Let's start on the left side.
Yeah.
Did y'all not get one? I'm sorry.
Right in the back.
Right back here.
Oh.
Sorry about that. Y'all Gucci now? We're Gucci now? We're fur? I'm going to do that. I'm going to send that to my wife. I should send it to my wife and just see what she says back.
Go for it. Do you want Chick-fil-A for dinner? You're like, question mark?
Yeah, that would be awesome. All right, this is what we ask. Okay, here's the ask. On the or side, we ask whether the events are the events what? 4 tickets.
Mutually exclusive.
Good job. Yeah, Jared, give yourself 4.
I did it 4.
No, you did not. I just said it quieter.
I heard Jared. Sorry if I messed up. It's not surprising. No, I'm
Yeah.
joking. I'm messing.
I literally only have 4 tickets.
This is also the same word. The gangsta name for mutually exclusive
Disjoint.
is disjoint. Nice. Okay, the second thing going down, there's 2 ways. The answer to this is either yes or it's no. Okay, so if it's yes,
What does that say on the side? Disjoint.
disjoint right here. That's just,
No. Oh, never mind.
does that make sense there?
Yeah.
Cool. If they are disjoint, then the probability of A or B, and by the way, U or the U is or, right? So it could be U or, is equal to the probability of what?
A times B.
A plus B
Plus B gets or.
minus the thing and.
If it's mutually exclusive, though, what do we know? We don't have to subtract, right?
Yeah.
Okay, you say, Coach, why? I'll show you in a second. If it's a no, then that instance, we actually have to subtract it, right? So if it's no, that they're not mutually exclusive, meaning there's overlap in a Venn diagram, when we do this, it would be probability of A plus probability of B minus, and this is where Ivana was going, minus the probability of A and B. This is where both would occur, okay? So if they're no, they're not mutually exclusive, meaning they have overlap, we have to subtract where both occur because we don't want to count it twice. If it's yes, then we just simply add them together. If you're good, say uh-huh. All right, I don't know if this is helpful. I'm hoping it is, okay?
It's helpful.
The last thing is if we are saying if they are disjoint, this is just reiterating what we said up here, then the probability of A and B, which is, by the way, just so you're aware, it's this part right here. This is equal to what if they are disjoint?
PA times PB.
True. So think about that. It's where the overlap occurs, right? What would that be equal to? Where would the overlap occur? Where, if I did multiply them, what would we know about that? It'd be 0. You would give yourself 2, Claudia. Because think about it. Give yourself. That was really bad. I was not meaning that. Y'all, I thought you said 2, Tony. My fault. I thought you said 2. I was listening and not listening at the same time. Give yourself 4. I'm so sorry. I feel really bad right now. This is awful. So this would be, I'm not for right now. That would be equal to 0, as Tony stated. Tony, will you forgive me?
You still don't understand what fur means.
No, I don't. Okay. Does that make sense? We're good? All right, let's go to the right side. The and idea. This time we're going to ask what? Tony, what are we going to ask on this one? This one was mutually exclusive, right? Left side. Tony, what would we ask on the and part? It's kind of the other one, right?
Are they independent?
Was that Tony? Was that you?
No.
Oh, okay. It would be independence. Yeah, it would be, are the events independent? All right, here we go. We'll roll down this one. We have 2 possibilities. The answers are both yes and no. Okay, so we got yes, they are, or 2 is no. By the way, this is very important for where we're going. Okay, so if it's yes, they are dependent, the probability of A and B is equal to the probability of A times the probability of B. Okay? All right, now what if they are not independent? This is a little bit different. Okay? The probability of A and B equals what? The probability of A times the probability of B given A.
Wait, what is that?
Okay?
What?
Probability of B given A.
What is that?
You say, Coach, how in the world did that work? Could I backtrack just for a second? Okay. If I go back here, remember this formula right here? Okay. Remember this is the formula, right? If I did this and solved it like an algebra formula, how could I get A and B by itself? Multiply it by B, right? So if I said, what is the probability of A and B? It would be the probability of B times the probability of A given B.
Got it.
It's the same thing I just stated. I just worked that formula backwards here. Does that make sense? So this is where it would not be independent. This is where it would be. Cool? All right, almost done. I appreciate y'all, and then we'll keep rocking. The last thing, if A and B are independent, that was pretty good, actually.
That was actually good.
No,
Was it?
yeah, I have to get that one.
Yeah.
That was good.
Yeah, you had like a note change and everything.
He got this too.
Wow.
He said, "I'm Beyonce."
I was feeling it. Come on, man. All right, that means this is too fun. This is the probability of B given A. That would be equal to the probability of B.
What?
All
Then
right.
why did we just write that?
Good question. Why did we write it above it? Because as we look at this, right? This part right here and this, if they're independent, those two are the same.
Okay.
Oh.
Oh.
See that? Because what? Bingo. Because why do I just put probability of B? Because it's the same whether it's probability of B given A or whether it's probability of B.
Right. Okay. I'm with you.
They're the same.
Can we
If
just
it's
go back to
independent.
like flipping heads and tails?
If it's independent. Remember when we went back on the previous one, Grace?
5.1 was so easy.
If I went right, hold up.
Yeah,
This
these
one
are the hardest
here,
chapters.
0.55, 0.55, 0.55, they were the same, right? So we would say in this case, probability of A is equal to the probability of A given what B is, because it's 0.55, is equal to the probability of A given not B.
I wish we could use this sheet on our test.
Does that make sense?
Hint, hint.
And
Please.
Okay,
I
I'll
want to
allow that.
pass.
Wait, for real? Wait, what?
For
For
You
real?
can use
For
You're all welcome.
You asked. You asked. No, I'll do that. That's fine.
Yeah, but
If the other class doesn't ask, I'm not going to allow them.
Oh.
And no one tells their class that.
That makes sense. We're good. So you can use that sheet and in your formula sheet. But please make sure you're familiar with this sheet, because if you are not, what's going to happen is that you're going to waste too much time trying to figure out what you wrote down. Got me? So you got to understand it, but you can use it. Okay?
Okay, for the AP exam, are they gonna give us the formula sheets, or are we allowed to take ours from this class into the exam? Like, how does that?
They'll give you a separate one.
They'll give us
But the
a
one that
separate
I've given to you is the one. It's the same one.
Okay, I just.
You first.
The only thing you won't have is what you see here. What you will have on here, just so you have a heads up here, is this. What's in green? They'll give to you, and then the probability of A or B formula, the mutually exclusive one. They'll give that one to you as well. Cool. All right. Hey, let's do this. What time do we get out of here?
55.
55. So what do we got? Oh, we got 12. This is perfect. We're Gucci. Okay. All right. It's hard to see this. Let me get a different color. You may. Yes, ma'am. Absolutely. Let's go to. Oh, that's bright. That's it. Right
I
there.
like it. I
I
like it.
like it.
All right. So, question here. This should be a separate sheet from what you have right now. If you want to put this on the side or somewhere else, this might be pretty good here. I want to just show or answer the following questions, okay? All right, so here's the, let me get this here. Okay, we've got here's our sheet. All right, let's see what we've got here.
Oh.
Oh.
Easy now. All right, so what we're gonna do here is, that's bothering me, that's okay.
It looks like a straight
How many of you,
Yeah, that's a straight
if
line,
you
yeah.
fit in this category, you got to raise your hand, okay? Of those that have an Instagram, how about this? Because some of you have both. When I say active, you post on there at least once a week. Cool? If you're active on whatever social media that's up here,
Oh,
Instagram or Twitter, okay?
Post on Instagram. Actually, never mind. I know what it is.
Yeah, that counts.
I think that's
Isn't that what you're supposed to do? Is post on Instagram?
once a
I thought
week.
it was
Yeah,
like
like,
once a
I mean,
week.
once a week. I mean, I get. Can we say get on it? Like,
Get on it.
okay.
Yeah, get on it. Yeah.
Fair?
Can I go to the restroom?
You may. That's fine. Hold up. You got to vote for us real quick. Twitter and Instagram.
I don't have
And then you can go.
either.
Neither?
Yeah.
Okay, so we got. How many of you have neither? No Twitter, no Instagram?
I'm an outlier.
Perfect. No, that's good. Okay.
No
Perfect.
Insta?
Here. How many of you would be Twitter and Instagram? You get on there all the time. 1, 2, 3.
Twitter and Instagram.
Twitter and Instagram. 3. Okay. How many of you have an Instagram but no Twitter?
I have both.
Or
Yeah,
like
I
check
have
it. You
Twitter.
know,
Oh,
6, 7, 8, 9.
Twitter's dumb.
Perfect. How many of you would be no Instagram but Twitter? That's right, Win. Me and you. That's right.
So 2.
2 of us. Okay. All right. Now we're gonna do this just real quick. Fill in a chart just somewhere off to the side. It could be maybe there's a blank spot in there. I think there's a blank spot maybe in your notes or on the back side there. We're gonna total this up to where we have 5, 11, 4, and 12. We got 16 total here. Okay. Now here's the question, and this is something you'll have to do come test day. I want you real quick, without putting context to this, because you might. By the way, what would context be for these ones, Fiona?
Would you like the P, the parentheses, and then A? Yeah.
It's perfect. No, yeah. And I would say, before I do that, give yourself 2 on that. A would be Instagram. Make sure you state this. Like, what are my variables? B is my Twitter, and then I also, to show work on an FRQ, I've got to use either a formula or I need to describe what's going on. If I describe, make sure it's very in-depth, okay? So in your groups, I want you to kind of figure out, are these independent events, okay? Are these independent events? First off, before we get started, is anyone confused on how I would show this? You all feeling pretty good on that? All right, show it real quick. Go ahead. And if you feel really Gucci, go to the second one. Okay, go to the second one. I'm sorry.
I think we should accept, but is
Yeah.
It just is. It's just like you look at the chart.
Absolutely, yeah. Yeah, you absolutely can.
I mean, like, okay, if I like you said about the card, if you take a card out, and then if I leave it in, probability. So I think the probability will change. The probability will change. Like if we get 3 out of 12, and then we get I'm sorry. So like P Twitter, right? So P Twitter. And then P.
Is this not making sense? All right, let's do this. Let's just talk there real quick. What's the probability that someone has Instagram?
I'm sorry, I forgot.
No.
12 out of
Great, yeah, because 12 out of 16, right? Some proportion, right? What is the probability that they have Instagram, given that they have or given that they have an Instagram? Well, I'm sorry. What is the probability that they have Instagram, given that they have Twitter, right? So they're given that they have Twitter, right? So what is the probability that they have Instagram? Great job. Now, before I go to the third one, are those two proportions the same?
No. No.
No, because this is 3/4. This is 0.75, and this is 0.6. That's not equal, right? So at that point, what I would do is once I show this on an FRQ, I would say what? It's not independent, or it's dependent. You could say either one, because probability of A is not equal to the probability of A given that a certain event occurred. So we would say at that instance, these are not independent, right? Does that make sense? If it was independent, that means these two are the same. Cool. And then also, this would also mean that this would be equal to probability of A multiplied by probability of B, if they were independent, right? Okay, what about mutually exclusive? We're kind of just talking through this. How could I show that one?
Oh, and probability of Instagram and Twitter is not 0, basically.
Great job. Josh, give yourself 4. Nicely done. That's the definition of mutually exclusive, right? Got it? That's mutually exclusive. Well, where is in a Venn diagram, if you get this, is that mutually exclusive? No, because there's this little gap right there, right? Where they overlap, and therefore it's not mutually exclusive, all right? It was the breakfast this morning. I apologize, okay? So what would be the probability of A and B in this instance, where both occur? 3 out of 16. Good. Who said that? Both of you did. Give yourself 2 each. 2 each. Nicely done. 3 out of 16, which is not equal to 0. So how could I describe that?
The events are not. Oh,
No, yeah, you could describe it. Go ahead, Charles.
oh, the events are not mutually exclusive due to A and B not equaling 0.
Yeah.
Is that
You
it?
could absolutely say it that way. Give yourself 2. I would also, in the context of this, we have a probability of both events occurring, right? Where someone could have an Instagram and Twitter, and because that number wasn't 0, now if this number was 0 here, where both occur, then we would say in that instance that it was mutually exclusive, right? Cool, cool. Fur. Okay? Awesome. Questions on that? All right, what could I use this then? Probability of A or B is equal to the probability of A plus the probability of B. Could I use that for this problem?
But you subtract by 0.
Well, if it's mutually exclusive, we'd subtract by 0. Good, Eric. Give yourself 2 on that. But is this mutually exclusive where it would have a 0? No, I'd actually, I'll put this in orange over here. I'd actually subtract what from this over here? Say again, Wayne?
P and B.
Exactly. Which would be what for us?
No,
Not
it's
three.
For this example, 3 over 16. Does that make sense? Because this is where both A and B, where they both occur. Okay? Am I making, did that help at all today? Okay, I hope that did. Those two events are, like mutually exclusive and independence, are just tricky. Are really, really tricky. Okay? Cool.